The last one here I did, and again, it's the same process I went through before. That's why you see all these lines. And the two questions here are really important. So ultimately, this was the final triangle after two rotations, one about D and then one about E. It says, can a single rotation around D map A prime, B prime onto A, B, and C? And the answer is no. The distance between D and point A is not the same as D and A prime. Therefore, no single rotation will work. So that becomes really quite important. Basically, there's no way for me to go from this triangle all the way to this triangle off of a single rotation, because there's no way for me to keep these distances exactly the same. So from D to A, I know this is roughly 4.5 centimeters, but from D to A prime, it's all the way out to like 6, a little more than 6. And similarly, it wouldn't work around E either. There's no way for me to map A prime, B prime, C prime back onto A through E, because as you can see, the distance between the selected points is completely different. It says, can you find a center that would map A prime, B prime, C prime onto A, B, C in one rotation? And there, yes, you can. It will be the perpendicular bisector of A prime, B prime, and C prime intersecting. So the point of intersection, let me reword that, making sure we understand what I was saying. The intersection of these perpendicular bisectors the intersection point of the perpendicular bisectors is your point of rotation. Okay. Please summarize the big ideas from each of these. They're each individually really important. Understanding the maintenance of angles and distance. Understanding that I cannot switch the point of rotation. And finally, that I can, if I have the same rotation,